My name is Christopher Zelenak, and this is my 10-minute presentation on chapters 1 through 6 for CompTI Network Guide to Networks. This is Network Foundations by myself. This is for course CMSC 345 by Kei Uebuo. That's the instructor. Why networking matters. Networks enable global communications and data sharing. Every organization relies on connected systems for efficiency and security. Modern networks blend hardware, software, and protocols to keep data flowing from point to point. Network roles and types of roles. Network types, we have large area network, LAN, WAN, WLAN, MAN, and PAN. Large area network, wide area network, WLAN, metropolitan area network, and then personal area network. For network roles, we have client to server and peer-to-peer models. Both do similar things but differently. And then the benefits of these network types and roles, depending on your choice, would be collaboration between teams, resource sharing, and centralized management of all online systems. How networks communicate. Networks communicate through a couple of different means. One of them is the OSI 7-layer model, which goes through the transport, then the data link, network, transport, session, presentation, and then application. And then you have the TCP/IP model, which is 4 layers, which involves network interface, internet, transportation, and then application. Data flows down the layers when sent and then flows up when it is received. Addressing the network, you have the MAC, or Media Access Control, which is the layer 2, which is physical address. You have your IP, or Internet Protocol, which is your 3rd layer, your logical address. You have IPv4, which is done in 32-bit versus IPv6, which is newer and done in 128-bit. DHCP automates IP assignment, while DNS translate names to IPs. Protocols and routing. TCP/UDP. For TCP, they deliver reliable transportation. UDP is used for more faster, yet riskier transportation. You have the risk of losing some packets in transport. Some of your key protocols include HTTP, HTTPS, FTP, SMTP, DNS, or ICMP. Routers can use static or dynamic routing, RIP, OSPF, and BGP. On the physical layer, we have cabling. Some of the cabling that is used often is copper or twisted pair. These are typically Cat5 or Cat6A, and these are coaxial cables, which means it's copper wires that are shielded around or shielded via like a plastic or silicone outing. Fiber optic is a new kind of cable where a small light node is shot through the light emitting rays throughout the cable, and that transports your data faster. You have 2 modes for that. You have single mode and multi-mode. Single mode is good for point to point, and the multi-mode is good for sending large swaths of data over multiple channels. You have several different types of connectors: your RJ45, your LC connector, your SC, and your ST. Cable management and testing tools can ensure your reliability. These could be things like labeling, color coordinating, cable continuity testers, speed testers, other testers like that. Multimeters, those are really good for making sure your cords are where they should be and running as they should be. For Ethernet and switching, your Ethernet, you have a standard LAN technology, which can range from 10 megabits per second to 400 gigabits per second. Switches is your second layer. Typically, these are forwarding frames and use MAC addresses to forward data to specific connections, that making sure they need to go where they need to go. Some features that you have VLANs, STP, and trunking, excuse me. Your switches versus your hubs. Switches are used for efficiency, and hubs are used for traffic control. So think large swaths of data versus a small network. Um, and then we have bringing it all together. So data travels from applications through network and layers to physical cables. Each layer, address, and device plays a unique role, and these fundamentals form the base for an advanced network design.